Hello everyone, welcome again. In this tutorial, I will give some basic introduction to the embedded system overall. Basically this tutorial is kind of for beginner. Okay, so let's get started. Okay, so first of all, I'll talk about the analog and digital signals. Okay, and then I will introduce the embedded system. Okay, then we will do some conversion between the microcontroller and the microprocessor, and we will see what's the difference between them. And also we will talk about the sensors and actuators. Okay, and then we will talk a bit about the programming languages. Okay, and then we will try to do some hands-on practice regarding the writing and reading data by using Arduino platform. Okay, so let's get started. So first of all, let's define a signal. Okay, commonly in any electronic device we have signals. Okay, signal actually is a voltage. Okay, is a difference in voltage between two points. In the embedded system overall, we have two kinds of signals: analog signal and the digital signal. Okay, so the analog signal, they are vary continuously in the amplitude within the time. So we can see here the first signal, the amplitude is vary within the time. It's going up and down. Okay, it doesn't got a fixed amplitude within the time. It will be vary, let's say, okay, this is the baseline, this is the 0 volt, and this is the voltage, this is the time. Okay, we can see here start from 0 volt, then it will go up, let's say maximum here is about, let's say 5 volts. Okay, it will start from 0, then it will be increased, let's say by 0.1, 0.2, 0.3, etc. until it reaches to 5, then it will go back 4.9, 4.8, 4.7, etc. until reach 0, and so on and so forth within the time. However, for the digital signals, they have fixed magnitude. Okay, if we can see from here, the magnitude is fixed within the time. Or it's not fixed actually, to be more specific and more accurate, it has only a single value of magnitude. Okay, or actually two, not only one, either 1 or 0 within a time. Okay, assume this is 0 volt, and let's say this is 5 volt. Okay, let's say 5 volts equal to 1, 0 volt equal to 0. So it has either either 1 or 0. 1 or 0. Okay, this is a digital. It will not be vary within the time. Okay, it will be fixed. Okay, next. Now let's talk about the system. If we want to define a system, actually there are a lot of systems in our life, so therefore we can say the system is a thing that we create to solve a problem. For example, we have a handphone, camera, cars, airplanes, all these systems, we create them to solve problems into our life. Okay, these systems got two type of system, which called computer system and an embedded system. A computer system is just a computer that we all know that can do multitask, can do many things by using only a single computer. Can we listen to music, can watch movies, can we do our homework, go to the website, etc., by using only a single computer. However, for the embedded system, if we want to define, if we want to define an embedded system, if we want to define an embedded system, it is based on a computer system. It's based on a computer system, but it works only for a dedicated functions. It will not be multitask, even though these days we can see there's a lot of multitask embedded system can do this, but the embedded system, the basic embedded system, is very dedicated. For example, for the phone, phones cannot do more than one thing. Can do only calls, cannot do more than one thing. For camera, only for recording. Cannot go to the online, cannot do your homework or browse anything using the camera, only for recording. This is the embedded system. Now, typically the embedded system architecture, it will be contained of an MCU, which is in the center of the system. Each embedded system must contain an MCU, which is a microcontroller unit, which control the operating of the system overall. And the MCU itself cannot complete the function of the system. It needs sensors to sense the environment phenomena. For example, if you want to sense the temperature, sense the vibration, sense the distance, sense the location, etc. Any physical phenomena you want to sense it or measure it. After the MCU will get the feedback or the data from the sensor. Then it will process it according to your code. Then it will update the actuator to do the required action. These three are the main component of any basic embedded system. So if you have a basic embedded system, at least you have these three with the power supply. But if you want to make it more fancy embedded system or make it more complete, you need a user interface. This user interface, it will help the user to interact with your system. For example, to enter some data or to extract some data, or you see the status of the system by using the UI or the user interface. At the same time, you might connect more than one embedded system at the same time. So they can share the job, or they can share the data, or even can transmit the data from one place to another. At that time, you will need a communication modules. This communication could be a wired or wireless. So these are the basic components and the advanced component of the embedded system. Now, since we say previously we need microcontroller for the embedded system, usually we will heard a lot about the microcontroller and microprocessor. Well, for the let's start from the microprocessor. Microprocessor, it is let's put it like this. Microprocessor is the processor that will process your data. It's only a processor. It's only a big fat calculator only. You can see here, this is the central processing unit, the CPU. So the microprocessor is just a big fat calculator that it will execute your code, but got no extra component, for example, RAM, ROM, I/O points, or even serial ports. Got nothing, just a processor, just process your data. So if you want to design your system using a microprocessor, you need to add on external RAM, external ROM, external I/O, external serial port. These all are external. Out of the chip. However, for the microcontroller, all these components plus more modules, they are all on the same single chip. For example, we got program memory, got RAM, microprocessor, analog to digital converter, oscillator, peripheral, and all the other required components in a single chip. So no need to add any external components. Okay, it's a complete system in a one chip. Okay, but then you can actually, there's an argument about this. Say if this one all complete in a one chip, then it should be better than a microprocessor. No, that's not true, because yes, you will integrate all these modules in a one chip, but you will sacrifice the capability of processing a complicated and high efficient code. Okay, so this one will not be, the microcontroller will not be as efficient as the microprocessor. Okay, and we can see from here that that the CPU require more, as we say just now, CPU require more component to be function correctly, whereby the microcontroller is a complete one system. Okay, and you can read the following comparison between the microcontroller and the microprocessor. Okay, and in this time, for this tutorial, we will focus on the Arduino as a microcontroller based platform, that we will use it to have some hands-on and also to learn more about the embedded system devices, or embedded system devices. So now, what is the pros of using the embedded system? For sure, it's cheap compared to microprocessor. Okay, and also it will reduce the number of components. As we say just now, if you want to use microprocessor, you need at least 3 to 4 extra chipsets to make the microprocessor work correctly. However, if you choose to use a microcontroller, one chip can perform everything. However, the cons of this, the microcontroller are less flexible, as we say just now. They are less flexible. Why less flexible than microprocessor? For example, in microprocessor, you want to update the RAM, update the hard disk, update whatever module you want, just like change one chipset. In microcontroller cannot, because everything already embedded inside. You have to change the chip, the full chip itself. Okay, and the second thing is microprocessor can be easily upgraded with the high specification. This is what we say just now. Okay, so now let's talk about the Arduino module. This Arduino module, as we can see, is based on Atmega chipset, Atmega 328 microcontroller. Okay, this is the one here in the middle, and from here we have our own I/O points here and here on the side. Okay, and here we have our communication port through USB to the laptop for coding, for uploading the code. And here we have the external power supply in case we need an external power supply. Okay, now let's talk about the pinout. For the Arduino, we have one channel UART. This is the RX and TX, pin number 0 and pin number 1. We have pin number 2 to pin number 13, they are digital I/O. Okay, and we have digital ground also here with the analog reference pin. On the other side, we have 6 channel analog pins, and also we have V-in pin. This one, if you want to supply directly the voltage from any external power supply directly to the microcontroller. Okay, but be careful with this one should be 5 volt, not extra, because this one will directly go to the microcontroller without any regulation. If you want to supply with regulation, you have to supply through here. This one, if you send from here, can go up to, if I'm not to say, up to 12 volt. I'm not sure. 12 volt, then it will go through this regulator that will regulate it before go to the MCU to the rest of the board. Okay, again we got the ground, and also we have 5 and 3.3 volt and the rest pin. Okay, let's go to talk about the sensors and actuators. Sensors and actuators, actually they are very important, as we say, in our system, whereby we use them to sense the environment, and they will help the MCU by providing the required data, and after the MCU, the microcontroller unit will read the data, process it, then it will send the signals to the actuator to do the correct action according to the sense data. Okay, sensor, actually, as we say, sensors, they are devices that will capture the phenomena or the stimulus from the physical environment, okay, and convert it into electrical signal. Okay, for example, we have temperature sensor, we have level sensor, distance sensor, etc. Actuator, they are opposite to the sensor. It's a device that it will produce the physical stimulus from an electrical signal. Okay, actuators, for example, we have speakers, motors, vibrators, LEDs, etc. There's a lot of actuators. Okay, you can leave a comment down below and tell us if you have more suggestions about the actuators or sensors. Okay, now regarding the programming languages for the embedded system, well, you can use any language that you're good in. You can use C, C++, Visual Basic, Assembly, whatever language you prefer, even Python, MATLAB. But at the end of the day, after you compile it, you have to convert it into a file with the extension of hex file. Okay, hex file is the only format that can be downloaded into the chipset, okay, or on the microcontroller chipset. Okay, so after you finish your code using any language you prefer, then it should be compiled as a hex file. Then you will take this hex file, as you can see this example of hex file. You will take this hex file and burn it inside the microcontroller, so the microcontroller can understand your code. Okay. So in this tutorial we will use C. Okay, we will use C language that it will already supported by Arduino. Okay, in this C language, is good to keep in our mind some how can I say, some tips that will help us to improve our code attitude. First of all, if we want to test the equality of two numbers, we should use double equal. Okay, this is important. Be careful, not one equal. If you want to test if A equal to B, you should use double equal, not only one. If not equal, you should use this symbol. Okay, if greater than or equal, less than equal, and if you want to combine two conditions, let's say if A equal to B and C less than D, and also not. And again, since we say just now that the embedded system is not really flexible and not easy to be upgraded, and programming memory is very limited and small, therefore it's our job to optimize our code to make it as small as possible and also as effective as possible by carefully utilizing our variables. If we can see from here that the integer is about 16-bit, this means it will occupy 16-bit of our programming memory. Okay, and if you go further, for example, short, long, or even long can go to 24 or 32-bit. So you have to be careful when you choose your variable, whereby long variables or yeah, long variables can occupy a lot of memory and give you no more space to add more code into your system. Okay, so next let's start to download our Arduino compiler. So I will put the link for you guys down below in the description. So please, you go to the software tab, you go to the Windows installer. If you have Windows, you can go to the Mac also if you have a Mac, and download it and install it. Then we'll come back after this. Okay guys, so assume you already have downloaded and installed the Arduino IDE compiler. So from here we can see, if you open the Arduino IDE for the first time, you'll see this interface in front of you. Okay, this is the main interface. Okay, this one consists of few buttons over here. That it will be help to compile, save, or bring new sketch. And also you will have this part over here. This one is for you to write your code, and this part over here will display the status of your code, whether there is an error in your code or any other warning. Okay, so first of all, the first button here, the tick or the correct mark, will be used to compile your code. The one beside the icon beside it, which is represented by an arrow, it will be used to upload your code into the Arduino board. And then the next one, it's used to call new sketch. And the second last one is to open an existing sketch. For example, you already saved your code, you want to reopen again. And the last one, it's used to save the current sketch. Okay, and the magnifier icon over here, this one is used to open the serial monitor, where we can receive any data. If we put inside our code inside our code we put some data to be displayed in the serial, so we click here to read this data. Okay, before we go further, it's also very important to choose the correct board and the port. Okay, you go to the tools, then you go to the board, then you have to choose the correct board, whether you use Arduino Uno or Nano, Mega ADK, Leonardo, whatever. You have to go there and select the correct board. Second one is to select the correct port. Okay, because these two, they are most important options. You have to correctly select them, so you will not get any error when you upload your code in the future. Okay, so now let's have some look about the program flow by using the C. So from here we can see, if you want to declare a variable, we use this format. It's just integer x, and this one's a float. This is how we declare it. Okay, again, we say just now that the MCU got a pin out that we can set it as input pins or output pins, or even to read or write the data to the other devices. So by using this format, the first one, pin mode, which is pin mode, then open bracket pin, comma, output. This one is we set this pin, let's say pin number 1, 2, 3, or whatever. Outputs mean we assign this pin as output. Or we use the same command, but we change to the input. This means we assign this pin into the input. Okay. Now, how to read the data from a pin? Let's say we already set this pin as an input. Now we want to read the data. by using this command. Okay, we set a variable with the name of value. Then we use a digital read of pin. Let's say digital read of pin number 5. Then we read the data from pin number 5, and we hold this data, or we save this data into the value. However, if we want to send the data to the pin, or we want to output the data to the pin, we use a digital write. Okay, digital write is to send the data from the microcontroller to the pin to the external device, for example, to trigger on an LED or motor, etc. Okay, by using this command. The value here actually got only two values, either high or low, 1 or 0. Okay, this one for digital pins, this one for digital pin. However, if you want to work with analog, you have to change from digital read to analog read. Okay, we have to change to analog read. And also, there are some kind of Arduino, like if I'm not mistaken, like Arduino DU supports a DAC, digital to analog converter, can output an analog, or even the Uno got something called PWM, so it will output an analog. But actually, for the Arduino, it's not an analog, but it's just a PWM signal. However, if you want to go for pure analog signal, you have to go for Arduino DU. Okay, by using this instruction, we'll output analog value. Okay, so here if you have an if condition, let's say if input pin is equal to high, again as we say, it should be double equal, then do this, otherwise do thing B. And for the for loop, this is how we do the for loop. Okay, it's a simple C. For example, here we are looping for 20 times to turn on and off pin number 13. Okay, while loop, this is how we do a while loop, and this is a do while loop. Okay, it's very basic C code. Okay, now let's move to the basic or the standard Arduino code. Okay, if you want to, let's say you want to upload an empty sketch or empty code into your Arduino, at least it should have these two functions, which is the void setup, void loop. For sure, this one no need, the statement here no need, this one also no need, but at least should have void setup and void loop. Okay, what's the difference between void setup, void loop? Actually, setup, it will be executed for once, whereby you will declare your variables, identify your values, your initial state for any variables, and the loop, it will be continuously loop through your code, that the one will be executed continuously. Okay, so now here we have a simple hello world, or what we call blink example, whereby we have an LED, built-in LED in the Arduino Uno that connected to pin number 13. Okay, so here, as we say in the setup function, we just declare for once that the pin number 13 is the output. This one will be implemented or be executed for once only. Then in our loop that will be continuously run, it will be set the digital write of pin number 13 to high, then on, then it will be wait for a second, then it will be turn it low or off again, and also wait for a second, then it will go back again to the void loop. Okay, this one will be continuously executing the code. Okay, so now if we run this code and hit the upload button, then we can see it's already compiled and sent to the Arduino without any error. But the most important thing that we haven't noticed is the hex file. where is the hex file? Because if I don't know if you guys remember back before, or for those old people, usually when we work with any microcontroller, say the PIC, or even the Atmega, usually we will have the hex file, then we will call the hex file into the programmer, then we burn it by ourselves using external programmer. For this one, luckily with the Arduino, everything is done automatically. It will convert the C code into a hex file, then it will be burned inside the MCU automatically without give you any headache. By give you the hex file, then you take the hex file to download in your chipset. Okay, so it will be done automatically. Okay, so now let's come talk about the writing data using Arduino. Okay, to write the data out, there are two ways. Let's take the first actuator, which is the LED, simple LED. Okay, for example, here is a simple LED. With this LED, got two pin, negative pin, short, and a positive on the long pin. Okay, in order to connect this pin to the any MCU, not only Arduino, we have two way of connection. Okay, either active high connection or active low. With active high connection is mean we are sourcing the current. Okay, active high is mean we are sourcing the current. If you can see here from the circuit, active high is mean the LED is already connected to the ground. Then when this one is high, this means 1, it will be active. Okay, well, that's why we call it active high. However, on the second circuit, on the active low, it will be sinking the current. Okay, active low is mean the LED is already connected to the VCC, and we have to sink the current into the MCU. So here it should be 0 to be activated. Okay, this is the difference. So if we have active high, we should send 1 to turn on. If you have active low, it will be turned on with 0. Okay, and here are the two connection circuits. Here is the what, active high or active low. Since the LED is already directly connected to the ground, so since they are connected to the ground, so they are active high. So it means when we send 1 to here to the resistors, it will be activated. This one, since all the LED, if you see this LED short and go to the 5 volt, the VCC, is mean they are active low. This means they will be function with 0. Okay. And also it's good to be mentioned here that the maximum current per pin, each pin of the MCU got a maximum current of 40 milliamp. Please be careful, don't overload the pin. Okay, don't overload it more than about 30 to 40 milliamp. Otherwise you will burn your Arduino. Recommended about like 20 milliamp. Okay, and also the maximum current from the power supply is about 200 milliamp. Okay, so now let's check the code for these two circuits, the Arduino code for these two circuits. Okay, so let's bring this one here. Okay, so first of all, if you see here, I have defined my 4 LEDs. The first LED pin number 2, 3, 4, and 5. Then we come to the setup function. I have declared all the 4 LED as outputs. This one will be activated for once. Then in the loop, this one first I will send high or 1. This means if I send this code to this circuit, at this point all the LED will be on for 1 second, then will be off for 1 second. On because they are on with 1, then will be off because I sent 0. However, for the other circuit, okay, for the other circuit, for this one, okay, let's enlarge this a bit. Okay, for this kind of circuit, for the one that active low, at this stage they will be off because they will be active only with 0 or with low. Off for 1 second, then will be on for 1 second. Because when come to here, this one will be on. Then when come back again to here, they will be off. Okay, so you can compile this code and upload to the circuit, and you can see if it's function or not. Please let me know if anything happened or you got any error in your code in your circuit. Let me know so we can discuss what is the thing you have faced. Okay, let's move next to the higher or bigger load, whereby we're using here a motor. As we say, maximum current can be drawn by the pin is about 20 to 40 milliamps. So how if I have higher load? If I have a higher load, it's very bad idea to directly connect it to your it's directly connected to your Arduino. It's very bad idea. Be careful. The good practice is to use external switching circuit. Okay, this switching circuit will be switch the external VCC to your load. This means not we take the VCC from here. We not take the power from here directly to the load. No, we have external VCC over here. Okay, this VCC will be supplying the energy to the load by using a signal from the Arduino, from any MCU. Okay, with this one we can solve the issue. Okay, so with here we can see the external switching circuit that we talked just now. As we saw just now, as we talked that we cannot directly connect the higher load, we have to use something called I always like this. Yes, something called switching circuit. Okay, this switching circuit, again we have two kind of switching circuit, which is again active high and active low. Okay, this circuit actually consists of a transistor. This is transistor. This is transistor also. Either a PNP transistor or NPN transistor. Here we have a PNP and here we have NPN transistor. Okay, so from here, this one is the active low circuit. Sorry, active low. So we can see that the load, this is our load, and this is our freewheeling diode. It's very important to add freewheeling diode to any induction load, like a heater or a motor. This one will be protect your circuit, your control circuit, from the reverse current after you turn it off. Okay, so if you can see here, the motor will be, or any load will be parallel to the protection diode, the freewheeling diode, and directly connect to the ground. And the transistor, the PNP transistor, will be controlling the signal from the VCC, which is 12 volt, to the motor, as we can see in the representation as a switch here instead of the transistor. Okay, and also we have a 1 kilo ohm resistor here, and from here go to the controller or the MCU. Okay, and here we can see the circuit. Okay, and here's the number of the transistor if you want to do it by yourself. Okay, the second one is the active high. The active high circuit will be active when it's high, when it's 5 volt. We can see that this one actually can be changed to the motor. We add a motor here with the diode. Okay, the motor here will be connected to the VCC, and we can see here this transistor will be controlling the ground. Okay, and again we have a resistor, 1 kilo ohm resistor to the controller, and again this is our circuit. And this one we can use the same example have we done just now by using digital write pin and the value either 1 or 0 to activate active high or active low. Okay, so now let's jump to read the data from push button or the tactile button. Okay, so as we can see here, so we have this button, and again we have two circuits to be implemented here. Okay, the first circuit called pull up circuit with pull up resistor, and the second one it's called with pull down resistor. Okay, with pull up resistor, I talk about the first one. With pull up resistor, this signal will go to the Arduino. Okay, so since the signal go to the Arduino, it means it's already pulled up to the VCC. So the Arduino will always read VCC when the button is open, and when press, this signal will go to the ground because of the pull up resistor. So if it's open, this one will be VCC. When pressed, this one will be equal to 0 or equal to the ground. Exactly opposite when we talk about the pull down. Okay, when it's open, this signal again will go to the Arduino. When it's open, because of this resistor, it will pull down to the ground. It will be always 0. But when it will be pressed, close, so this signal will be equal to the VCC. Okay, so in order to write the code for these two circuits, we simply use this code here, or this instruction. We use the digital read pin. Okay, so here let's see the code for the digital read pin. Okay, here it is. Okay, so first of all, we define the button that we have here is pin number 8. Okay, here is connected to pin number 8. Then we define a serial. This serial again to see the status of the button, was it pressed or no. And also we define the pin as an input. Okay, then we come through the loop. In this loop, I define an integer of the button state, which it will be read the state or read the digital read of the push button, which is pin number 8. Okay, after it will read, this one's mean it will take the status of the button and store it into the button state. Then I will use serial.print to print the status of the button. Okay, so you compile it, then you just upload to your Arduino after you construct the circuit, and please let me know if anything goes wrong with you. Okay, so we have finished from the tactile button. Let's move to read an analog signals. Okay, and analog signals, actually we can simplify it by using a potentiometer. Okay, in this potentiometer we have three pins, 1, 2, and 3, which is same as here. Okay, we have a full resistance between pin A to pin B. This is the full resistor of the board. Let's say this is 10K. If it's 10 kilo ohm, let's say this is 10K ohm. So between A and B, it's 10K. However, between any one of these pins with the wiper, the W, the resistance will be vary according to the angle of the rotary pin that on the top on this one. Okay, whenever you move this one, then the resistance between any of these two pins, A and W or W and P, will be changed. Okay, this one will be changed actually according to the voltage divider over here. If we take this as a resistor here, and we can change to 10. Yes. Okay, if we take this as a resistor, let's say we take the resistor here, come to here, and from here is another resistor, come to here. So actually we have resistor 1 here and resistor 2 here, which is same as here. Resistor 1, resistor 2, and this is the W or the wiper, and here pin number A and here pin number B. Okay, so by changing these two resistors, the output, the V out here will be changed. Okay, by connecting it to the Arduino according to this circuit, then we can read the variable voltage at A0. Okay, so we can see the code over here. I have wrote the code for the analog to read the analog reading from potentiometer. First, I define my input as A0 for the channel 0. Okay. Then again, I use serial.begin, this one to read the data from the Arduino by using this serial monitor. And also I declare in as input. Then when it comes to the loop, first of all, I assign an integer here, integer sensor value, to read the analog value of the in. Okay, take the analog value from here and store it into the sensor value. Then I use serial.print to print the value on the screen. Okay, so again, please try this on your own and let me know if anything goes wrong with you. Okay, so with this, let's move next to, I guess, our last slide. Yeah, so from here, now if from our previous slide, from here, okay, if we use this code, let's change to highlighter. If we use this code, okay, or this instruction, it will be display only the analog reading. Okay, it will display only the analog reading. It's not the voltage that it's been supplied to the pin. Okay, it's just analog reading. So how we convert the analog or the ADC reading into a voltage? Okay, we use this equation. Okay, we use this equation to convert from the ADC reading to analog voltage. Okay, from here, go to the pen. From here, we can say that ADC resolution for the Arduino Uno is 102 3. 0. Okay, so 1023.0 is the ADC resolution. System voltage for sure is just a 5 volts. Okay, and then ADC reading is the same as this one, which is the analog reading. This one is the same like here. Okay, then we calculate this. Okay, how we calculate this, how we transfer this into a coding, we come again to here. Okay, we will change something here. Okay, first of all, I will declare a new float because I want to see the more accurate reading. Instead of integer, I need some precision reading. So I will declare float, let's say voltage equal to. First, I will take the analog reading, which is here, or the ADC reading. Then I will multiply by 5.0 divide by 1023.0. Okay, so from here I will convert the analog or the ADC reading into a voltage now. Now when I print the voltage, now I can see the voltage that is being supplied to the pin, not the analog reading, because before that in the previous example we can see just a number between 0 and 1023 samples. This is just the ADC sample, but now we can see a number from 0 up to 5 volts. Okay, so please try this again and let me know if something happened or you didn't get the exact number. Okay, so with this we have finished our tutorial for today. Thank you very much. I hope you have learned something new. Please let me know if you need more, if you have any comment on this tutorial. Thank you very much and see you soon.